Height above given level.
Height above given level. So I hope as part of leveling I've already covered. So how do you measure elevation? With respect to what or with reference to what? Hmm?
Mean sea level, sir.
Mean sea level. 67?
Yes, sir, means 11.
67? 67, are you there or you just joined the class and kept the mobile aside and went away? 68? 68. Lot of people are here. The people list shows all here, but there is no response from any one of them. Hmm? 31 students are there. 71?
Yes, sir. 67, 68.
Yeah, tell me. Where is the mean sea level for India? With respect to what mean sea level or with respect to which place you'll measure all the elevations in India? What is the reference point? Where is the reference point? Hmm? 82?
Yes, sir.
Yeah, tell me the answer.
Maybe from Mumbai.
Maybe. Why not Goa? Why not maybe Goa? Any other answers? Hmm?
Sir, from Mumbai High.
From Mumbai?
Sir, 160 meters above from Mumbai, sir. Like Mumbai Sea, high sea.
Mumbai seaport is taken as a reference point for all elevations being measured in India. The big Mumbai seaport elevation is treated as 0 meters. Okay. So why we need these elevations and how do we get these elevations is nothing but what we are going to learn by learning the concepts of contouring. Okay. So a contour is nothing but an imaginary line on the ground surface joining the points of equal elevation. So it's an imaginary line which joins the points of equal elevations. If you take any ground surface, okay, there will be many undulations and the elevation of one point to other point changes, but there can be many points on the ground surface itself whose elevation will be similar. For example, if you take it as a 500 meters, there may be many points on the ground surface whose elevation or whose reduced level with respect to Bombay seaport may be 500 meters or 400 meters or 410 meters or 430 meters. Okay, so it's simply a line joining on the ground surface whose elevations are equal. So if you can see in this figure, there are 4 to 5 points. Okay, these points are existing at different places. The line joining these different points at different places who are having an elevation value of 400 meters is called as a 400-meter contour. And similarly, there's another example you can see there is a 500-meter contour. Okay. So we are simply going to measure what is the elevation or what is the reducer level at any selected point on the ground surface, and we are going to define that as we are going to join all those points and we are going to define it as a contour. Why this contouring is required? I hope I already covered this in the leveling part. Why contour values or why elevation values are required, especially for civil engineers. And don't get confused between the elevation of a contour or a elevation of a point on the ground surface and elevation of your buildings. That elevation and this elevation is different. Okay? But why do we need the elevation values or why do we need the contour values, especially from civil engineering point of view? In simple, in one word, I would like to convey without leveling and without contouring, there is going to be no existence of any civil engineering project. You take up any project, roadways, railways, building, dams, reservoirs, XYZ works related to construction activity. Everywhere you need this elevation values or contour values. It's mandatory. Without that, you can't do anything. But why that is required? You're having some figure on your screen, right? On the left hand side, you're having two lines, and on the bottom, you're having around 4 to 5 lines. So, what can you infer from this? Hmm?
Ground surface, sir.
I want some responses from you all people. Please don't expect that if you don't respond, I will simply keep on telling and going. That is not the way of my teaching. My way of teaching is definitely a participative teaching where you need to definitely respond. Okay. So here you're having one figure, the selected one I have shown you, and here you're having one figure. So what can we infer from this? Those two are the contour lines. The dark blue lines are the contour lines, and the light blue line is assumed that it's a road alignment or rail alignment. That is the elevation at which you want to lay a road or at which you want to lay a railway line or a canal, whatever it may be. So what can we infer from this diagram based on your leveling knowledge?
Ground surface, sir, cutting or embankment.
So if you look at this first figure, which is on the top left, okay, there are two contours, okay, and the design elevation or the design RL of your road is passing like this. So what do we mean to say here? Here the contouring value is this much, okay, but I want here the elevation is at a higher end when compared to my required elevation. Okay, this is my required elevation. Blue line is my required elevation at which I want to lay the road. And this dark blue line is the elevation which is existing at the ground surface, natural ground surface. Okay, the natural ground surface is starting from here and coming, it is reducing, it is going downwards, and again there is a form of a depression here, and again it is increasing, and again it is becoming almost normal in line with the starting point of this contour. Okay, so if I take up this line, this is my RL or reduced level or elevation at which I want to lay my road network. So from here to here, what is happening? If I take from here to here, up to this point, I'm having excess ground here, right? I want my construction to happen at this point, but my ground surface is this, existing ground surface is this. So the existing ground surface is at a higher elevation than compared to the required elevation or the design elevation, right? So what I need to do in order to bring this ground surface to this level?
Excavate, sir.
We need to excavate or we need to dig the earth. Okay. So move to the second portion of this figure. In this scenario, the existing natural ground surface is at a very lower level when compared to the design RL of my road. So what I need to do here?
Foundation.
Huh?
We need to keep
Filling, sir.
foundation. Filling.
Filling. తిన్నరా అందరు బాగా లంచ్ చేశారా? లంచ్ చేశారా లేదా? గట్టిగా మాట్లాడాలి. Okay, so in this case you are going to fill the earth, that is your మీరు మట్టితో దాన్ని పైకి లేపుతున్నారు. Then come to the third portion. What you need to do from here to here?
Again excavate.
We have to dig.
Excavate. So the basic purpose of a fire doing the contouring experiments or doing the contouring exercises is to define as in combination with the levels. If you don't do the leveling, you can't get the contouring. Okay, contouring is not the first. Leveling is the first operation which need to be done in order to prepare a contour map of a given area. Okay, so first you need to take up the levels of the existing surface, then you need to prepare the contours, then you need to overlay the designed RLs over the contour map in order to find out how much amount of earthwork has to be excavated, how much amount of earthwork has to be filled. Okay, so that you can prepare a detailed project report on amount of earthwork to be procured if the earthwork which you are digging here is not sufficient in filling the depressions. Okay, like this, assume that there is a 1 kilometer stretch of road which you want to lay, and the contour is like this, alternate. Okay, so you can estimate how much quantity of earthwork is excavated here and how much quantity of earthwork is to be excavated here. Assume that it is X and it is X. So 2X amount of earthwork is being digged by you. Whether the 2X amount of earthwork digged is sufficient to fill this portion. Okay, if so, no issue. If not, from where I need to procure the other portion of the earth in order to fill this depression. So what will be the corresponding cost for that? How much amount of labor is required? How much quantity of earth is required or moram is required? How many loads of lorries are required to transport the material from other place to here? What are the associated costs? All those can be done with the help of these things. Okay, the whole project report, preparation of a project report is dependent on these kind of activities. Okay, so if it is sufficient, if you are excavating whatever you are excavating in the portion 192, if it is sufficient to fill point 2, point 193, the portion of earth which you are excavating from portion 193, if it is sufficient to fill part 2, it's okay. Otherwise, again you need to look for other alternatives. Okay, that is the advantage of this contouring, and it is very much needed in all the surveying, in all the construction activities. Even if you are doing the construction of a small house also. Okay, you will be filling the earth right from the plinth up to the plinth level, from the ground surface to up to the plinth level. You'll be filling the earth. Above that, you'll be laying your floor. So, how much quantity of earth is required? Okay, here earth is nothing but మన తెలుగులో మట్టి అంటాం. ఎంత మట్టి లేదా మొరం వాడతాము మన బిల్డింగ్ ని నింపడానికి, కింద బేస్మెంట్ నింపడానికి. సో ఆ క్యాలిక్యులేషన్స్ అన్ని చేయడానికి we need contour maps. That is one application of contouring. Okay, likewise you have many other applications also. We'll see one by one. Okay, so a contour map is a map showing contour lines. Okay, most of the cases we generally don't prepare only contour maps. We go with the another map called as topographic map, which also consists of contours along with other features like water bodies, urban areas, forest areas, like that. Okay, but if you want a detail, the topographic map, is the screen visible to you all? Yes,
Yes,
sir. No?
sir.
So this is a topographic map of 1:25,000 scale prepared by Survey of India. Okay, wherein you will be having all the features. You can see at the bottom legend, you'll be having various features. Roads are there, bridges are there, dams are there, wells are there, railways are there, contours are there, sand features are there. You can see at the bottom second, it is a contour. Okay, this is how it is being represented in brown color with some value on it. Okay, so this is a base map which we'll be using for determining the elevations in the project site. But if you want a detailed contour values, like at a smaller elevation, smaller interval, these maps provide you contours at an interval of 10 meters, 1:25,000 K. 1:50,000 K, 1:50,000 scale Survey of India topo sheets provides you the contours at 20 meter intervals. So if your project needs a lesser contour interval, these maps are not sufficient for you. So then you need to go for a separate preparation of contour map using your auto level or leveling operations, wherein you can develop reports for 1 meter or 2 meter or 3 meter, depending on your requirement as well as depending on the existing ground surface. Okay, if your ground surface is steep, then you can go for a larger interval, because if it is steep means there is a clear variation. You can see the variations on the ground surface, undulations. But if the ground surface is flat, should I go for a longer interval or should I go for a smaller interval?
Smaller intervals.
If it is a flatter surface, it means that there are very less amount of undulations or very less amount of variations in the elevation values. So if I take an interval of 10 meter or 20 meter, okay, it will not give you any purpose. It will not fulfill your purpose. So you need to go for an interval of 0.5 meter or 1 meter or 0.2 meter, depending on your project site area also. Okay. So if you are going for construction of a small house, go for a contour interval of 0.2 meter or 0.1 meter. Okay, hardly you'll be getting 5 to 6 contours, because your whole building, if it is a 2 BHK, what will be the approximate length of a width or length? Around 10 to 12 meters, not more than that, right? If it is 30 feet by 30 feet or 40 feet by 40 feet, 1600 SFT of building, okay, 40 feet means you will be getting how many meters? It's approximately 12 meters to 12.5 meters. So go for a lesser contour interval in order to determine the earthwork requirement. If it is a dam, if you go for a lesser interval, what will happen to the project cost? A dam will be consisting of huge amount of area, right? Around 1,000 square kilometers or 500 square kilometers, 600 square kilometers of area will be there. So if you go for a 1 meter, 2 meter interval there, it will take years to complete your project. And the purpose is not that the purpose of the dam is to hold the water. Okay. There, if there is a variation of 1 meter or 2 meter in between two contours, it doesn't matter for you. Okay, so in those cases, you'll be going for a larger contour intervals because the area to be covered is more. So like that, depending on the purpose for which you want to develop a contour map, you can develop using your auto leveling processes. Okay. How we'll do that, I'll tell you again, but I want to show you today what is the contour, how it is represented in the map and how it is used in the maps. Okay. If you are able to see here, are you able to see any brown colored images? All of you, please see, look at the screen and tell me. Are you able to see any brown colored lines?
Yes, sir.
Yes, sir.
Yes, sir.
In addition to that brown colored lines, are you able to see any numericals?
Yes, sir.
Rule number 90.
Yes, sir.
Tell me any one numerical value which you are seeing.
556.
556. Not 556.
Sir, it is middle. Sir, it is
No, I am asking you only the numerical values associated with the brown colored lines.
638.
638. Okay. Any others?
10.
Any others? Please tell me
600.
any other value.
600, sir. 600, 550.
600.
600, 550, 638. You are able to see. If I'm not wrong, I am able to see only three values, right? 600, 550, and 638. Okay, those three values I'm able to see. Now you see and tell me what are the values you are able to see. Only with associated with brown colored lines.
530, sir.
530,
520.
520.
120.
ఇంకొకటి ఉంది.
640.
Hmm?
40.
640.
సార్ 550 కూడా కనిపిస్తుంది సార్ కింద.
You are able to see 520, 530, 540, and 550. So these are all called as contours. Okay. This is a 530 meter contour interval. Contour. This is a 520 contour. This is a 540 contour. Wherever my mouse is moving, please look at that. And this is a 550 contour. Okay. So all these are represented in a topographic map, and this forms the basis for all your civil engineering excavation works. So here you can see, here it is 550, or if I am not wrong, you are able to see a 550 value. So at the center, you are having a 638 value. Okay. So this first line is 550 meters, then second line is 560, third is 570, 580, 590, 600, 610, 620, 630, and this is the 638 meters is the highest elevation in this area. That is the topmost part of your Devatal Gutta, which is opposite to our college. Okay. So like this, you'll be representing the maps. Like this, you'll be representing the contours in the maps. Okay. And one major point which you need to remember is every contour closes on itself. That is a 600 meter contour interval will close on a 600 meter contour interval only, contour only. A 600 contour cannot join with a 590 contour or a 580 contour. Why? Can any one of you respond? Can a 600 meter contour and a 590 meter contour intersect?
No, sir.
Just show you.
No, sir.
Assume that this is a 600 meter contour. Okay, first one. Then assume that this is a 590-meter contour. Is there any possibility of an intersection like this? If yes, why? If not, why? ఇక్కడ మీకు ఇంటర్సెక్షన్ కనిపిస్తుంది కదా ఈ టూ లైన్స్ దిస్ పాయింట్. Is it possible that two different contours can intersect each other?
No, sir.
No? Why? Simple answer.
They are not at same elevation.
They are not at same elevation.
Yes, sir. Different.
So can you put it in any other word? You take any point on the ground surface, okay? It can have only a unique elevation. If you measure this point on the ground surface, it can either have a 600-meter elevation or a 590-meter elevation, but a single point cannot have both the elevations of 600 meters and 590 meters. Okay, that is the reason why no two contours will intersect each other. So this can never be happen. Only the contour, if this above one is 600 meters contour, then it should definitely be below this. Okay, because what we are saying by a contour is an imaginary line joining points of equal elevation on the ground surface. So when you say that this is a 600-meter contour, that means you are saying that at this point, the ground is at an elevation of 600 meters from mean sea level. So when you're drawing a 590-meter contour interval, again, how you can get the same point, 590 meters for the same point, which you have already defined as 600 meters, or which you have already measured as 600 meters. Okay, so that is the logic. So no point on the earth can have two different elevations. Either it can be 600 or 500 or 400, whatever it may be, it will have only one elevation value. That is the reason why whenever you are drawing the contour maps or whenever you are preparing the contour maps, you need to ensure that two successive contours cannot cross each other. There should be a variation. Okay, so that is one of the most important characteristic of a contour line. So this is the basic contours. Okay? We can treat this as a contour map also if you want to work only with the contours. Otherwise,
Sir, contours overlap avachcha, sir?
that is what I'm saying. Contours can't overlap because at a single point you will have only single elevation, right? What is contour?
At some distance lo same elevation ఉండొచ్చు కదా sir?
At some distances lo
Same elevation ఉండొచ్చు కదా sir?
Same elevation? No. Come again. Ask me again. What you want to say? మళ్ళీ చెప్పండి అమ్మ ఒకసారి. Please repeat the question. I'm not able to understand. Am I audible?
Sir, every contour closed path కదా sir? ఆ క్లోజ్డ్ పాత్ అయినప్పుడు ఒక క్లోజ్డ్ పాత్ ఇంకో క్లోజ్డ్ పాత్ ఓవర్లాప్ అవుతాయా సార్?
ఓవర్లాప్ అవ్వవు. ఓవర్లాప్ అయిందంటే ఎలివేషన్ వాల్యూ డిఫరెంట్ కాదు కదా. ఇప్పుడు సపోజ్ యూ టేక్ దీస్ టూ సర్కిల్స్ విచ్ హావ్ డ్రాన్ హియర్ రిప్రజెంటింగ్ an elevation of 500 meters and 400 meters అనుకోండి. Okay, so you take any point on this contour across this line, the elevation on the ground surface will be 400 meters only. And if you take the outer one, the elevation on any point along this line will be 500 meters only. So this scenario can't exist. Crossing two contours scenario can't exist.
Sir, in between interval లో ఉండొచ్చు కదా సార్?
In between
ఈక్వల్ ఎలివేషన్ ఎక్కడైనా ఉండొచ్చు కదా సార్?
In between equal elevation you can have. But suppose I'll show you some cases here. Here you are able to see 550 meters, right? In this map.
Yes sir.
Or let us take the example of 600 meters here. Here you are having a 600 meters line. Here also you're having a
Yes,
6
sir.
meters, 600 meters line. This is
Yes,
a
sir.
possibility. You can have this kind of possibility, but a 600-meter contour line cannot cross with a 590 or 610-meter contour line. That is what I am conveying. Okay. ఇప్పుడు ఇక్కడ కూడా 600 వస్తుంది కదా, 638 ఉందంటే దానికి తర్వాత 600 వస్తుంది కదా, 620, 610, 600. Here also it is 600. Here also it is 600. You can have same elevation values at different locations, but what I want to convey is two contours cannot cross each other. Two contours in the sense, a contour is nothing but a line joining equal elevation. So two contours under two different elevation values of it. Okay, so they cannot cross each other. That is what I want to convey. Okay. So a contour map is different from a topographic map. A topographic map consists of all features, all land features, whereas a contour map consists of only a contours, okay, of selected interval or selected scale. Okay. This I already told. The process of tracing contour lines on the surface of the earth is called as contouring. So what is the purpose of contouring? So this I already explained. The major purpose is, okay, it's carried out at the starting of any engineering project, such as a road, a railway, a canal, a dam, and a building. Whatever construction activity you take, most of the cases, 99.99% cases, it involves contouring and leveling, because there is definitely an activity of earthwork excavation or filling in any project. Okay, and it is also required to determine which is the most economical or suitable site. Okay, what do we mean by this most economical or suitable site? If I
In
want
cost
to,
wise,
if
sir.
I want, yeah, in cost wise, no doubt. If I want to, I'll just draw once more. I want to lay a road line from this point to this point. Okay. So what I will do, I know what is the design RL at which I need to lay the road. Then 500 meters దగ్గర above mean CL road వేయాలా, 400 meters దగ్గర వేయాలా అన్నది నేను డిజైన్ చేసుకుంటా ఆఫీస్ లో. Okay. Then I will overlay this on the existing contour map. Okay. Then what I'll do after I overlay this, I can determine how much amount of earthwork to be excavated, how much amount of earthwork to be filled అన్నది నాకు ఈ ప్రపోజల్ లో, ఈ ఆప్షన్ లో తెలిసిపోతుంది. So I'll check, is there any other possibility? Assume that the total project cost of this is 100 crores. So before proceeding, I would like to check, is there any other possibility of reaching this area from here to here or in this direction? Okay. Is there any possibility? Why I need to check this is, from this figure, it might you might get an impression that you are traveling a more distance. Okay, but assume that it is around 20 to 30 kilometers of variation only is there. Okay. So why I need this? If the ground surface in this first case is very undulating, okay, in this first case, straight stretch, if the ground surface is very undulating when compared to your design RL, okay, the amount of earthwork excavation and filling and its associated cost may be more. If you take the second case, the ground surface may be not much undulating. Most of the cases, it may be a flat surface. Okay, then in that case, the amount of earthwork excavation and filling may be less. And similarly in the third option. So I'll do a viability, feasibility check. I'll do, if I go with the straight stretch, what is going to be my project cost? If I go in the second stretch, what is going to be my project cost? And in the third option, what is going to be my project cost? And I'll do a comparison whether by increasing the road length by 10 kilometers or 5 kilometers or 20 kilometers, depending on the area, okay, which option is feasible for me, and then I can submit the project report to concerned authorities and they will take a final call which is feasible. Because sometimes what happens is, the major hurdle in executing any of the civil engineering projects is acquisition of land. Okay, you need to procure the land from the people, right? And if the area, if this first scenario, not only from the contour map point of view, but if it is going to from the city, the cost of the land is very high. So your overall project cost also goes high. So if I increase my road length by 10 kilometers or 15 kilometers, whether my project is going to be feasible or not. I'll do such kind of analysis. So for doing that analysis also, I need to consider the contour map, because by I'm increasing the length of the road here, so obviously the project cost increases. Okay, for laying a 100-kilometer road, you will be having some X amount. For laying a 110-kilometer, you'll be having X plus. 115 also you'll be having X plus. So if I change the alignment based on the effect of the cost of cutting, excavation and filling, will it be balanced or not? I can do such kind of analysis using these contour maps and provide different alternatives for the road alignment or track alignment, railway track alignment or canal alignment. All those things can also be done with the help of this contouring. That is what here I have mentioned. For preparing the contour maps in order to select the most economical or suitable site. Okay. That is the reason why you see many of the times the roads will be in curved manner. You can't find straight roads in many cases. Hardly in some areas you'll be finding the straight stretches, but most of the cases you'll be finding only curved roads. Okay. And to locate the alignment of a canal so that it should follow a ridge line, it's also applicable for a watershed. Okay, we need to have an information of ridge lines or valley lines in order to delineate the watersheds. Okay, and to mark the alignment of roads and railways so that the quantity of earthwork both in cutting and filling should be minimum. This I already explained. Okay, and these are general purposes of contouring, whether the ground is flat or undulating or mountainous. Why this information is required? Why the contour map is required to understand this point? Whenever you start any engineering project, okay, no one will visit the site. If I want to do a construction of a Polavaram project, I am staying in Hyderabad, and if the government decides to start that project and gives the work to a chief engineer, okay, he will never go to the Polavaram site. Why? Or he will never go to the site to identify which is the best site to construct a dam. Don't take the names. Okay, let us assume that I want to construct a dam. Okay, and the site is in Hyderabad. Yeah, sorry for the technical glitch. Power cut. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
So what is the first primary factor we need to consider before going for construction of our building or any reservoir? Let's take the example of reservoir only. What is the basic requirement we need to find out first? Hmm? చెప్పండి ఏం చూడాలి ఫస్ట్ రిజర్వర్ కట్టాలంటే
Site, sir.
Location.
సైట్ అదే సైట్ ఏం చూస్తారు
Map, map,
నార్తా
Contour map.
map, sir.
contour map is used to identify the location for reservoir but what is the first thing we need to look after మనకి ఏం కావాలి రిజర్వాయర్
Type of
కట్టాలి అంటే
type of soil, sir.
what type of soil you are coming nearer
Water area.
water
Water holding capacity, sir.
water holding capacity can you're almost here can you keep it in any other words
Water flow, sir. In water.
Valley shape, sir. Valley shape.
yeah where are natural depressions you need to first look after where are hills where are natural depressions why natural depressions are required natural depression by itself can store water right if you want to construct a reservoir okay assume that there are 100 villages which are going to which is going on the 100 villages where you are going to construct a reservoir okay and if you construct a dam or a barrage the water will be stopping there okay and if you want the height to be 100 feet or 200 feet or 300 feet height of water should be stored can you dig 500 feet of earth for assume that for 10 square kilometers of area చేయగలమా 10 స్క్వేర్ కిలోమీటర్స్ ఆఫ్ ఏరియాలో మీరు డ్యామ్ కట్టాలి అనుకుంటున్నారు ఓకే ఆ రాజ్యం బెస్ట్ ఎగ్జాంపుల్ టేక్ ద ఎగ్జాంపుల్ ఆఫ్ హుసేన్ సాగర్ హుసేన్ సాగర్ ఏరియా ఎంతనో మీకు అప్రాక్సిమేట్ గా తెలుసు దాని ఎలివేషన్ ఎంతో కూడా మీకు తెలుసు కెన్ యూ డిగ్ ద ఎర్త్ టిల్ ద డెప్త్ ఇన్ ఆర్డర్ టు హోల్డ్ వాటర్ చేయగలమా
No, sir.
చేయొచ్చు మనిషి తెలుసుకుంటే చేయొచ్చు బట్ వాట్ ఈస్ ద కరస్పాండింగ్ కాస్ట్ ఇన్వాల్వ్డ్ ఇన్ దట్ అండ్ వేర్ డూ యూ ఫిల్ దట్ ఎర్త్ విచ్ యూఆర్ డిగ్గింగ్ ఇప్పుడు నేను తవ్వుతాను హుసేన్ సాగర్ కోసం మట్టి తవ్వుతాను నీళ్లు ఉంచడం కోసం తవ్వుతాను ఆ తవ్వడానికి మట్టి మట్టి తవ్వడానికి ఎంత ఖర్చు అవుతుంది ఆ తవ్విన మట్టి నువ్వు ఎక్కడ పోస్తావు మళ్ళీ ఓకే సో దట్ ఈస్ నాట్ ప్రాక్టికల్లీ ఫీజిబుల్ సో వీ నీడ్ టు ఐడెంటిఫై లొకేషన్ వేర్ దేర్ ఆర్ న్యాచురల్ డిప్రెషన్స్ ఎగ్జిస్టింగ్ న్యాచురల్ డిప్రెషన్ ఎగ్జిస్టింగ్ ఉంది లార్జర్ ఏరియాలో అంటే యూ కెన్ స్టోర్ వాటర్ దేర్ విత్ మినిమం అమౌంట్ ఆఫ్ డిగ్గింగ్ వర్క్ ఇప్పుడు ఒక 100 feet డిప్రెషన్ ఉంది ఐ వాంట్ టు కన్స్ట్రక్ట్ వాటర్ హోల్డింగ్ డెప్త్ ఆఫ్ 150 feet or 200 feet so obviously my additional 100 feet of digging is avoided right okay so my project cost goes down by 50% so I need to identify those kind of areas where it is naturally existing and that can be done by using your contour maps okay so I'll show you the best example here you can see you are having some 500 meters 600 meters so can
So your PPT is not visible, sir.
PPT not visible huh? Okay sorry I'll present it is it all visible now
Yes, sir.
okay now seeing this image you can see from 550 meters to it is going up to 638 meters so it's a representation of a hill can you select this site for reservoir construction can you select this site for reservoir construction
No, sir.
ఎందుకంటే అది గుట్ట ఇట్స్ ఎ hillock okay so if you want to construct a reservoir there how many feet how many meters you need to dig above ground itself it is 638 meters and you need to dig again underground another 200 or 300 meters depending on your water holding capacity మనం 100 TMC సేవ్ చేద్దామా 150 TMC సేవ్ చేద్దాం అనుకున్న దాన్ని బట్టి you need to dig 100 or 200 or 300 meters okay so simply by seeing this contour map you can come to a conclusion that this site is not suitable for reservoir construction, right? So like that, you can easily identify where are the areas where you're having a depression. Okay. So you can, from this contour map, you can see here why all the water is coming and falling in this lake. There is a Masab Cheru while we are going towards Ibrahimpatnam. Why all water is coming from Guramguda and draining into this tank? Because it is at a lower elevation. Okay, naturally it will be at a lower elevation, because here you can see this is a contour map. This is a contour value of this one. How much is the value? This is a contour value of 530 meters. This one, and here you can see there is a contour value of 520 meters. So there is an elevation difference of 10 meters here. That is why the water is traveling from 530 meters to 520 meters. So obviously, if there is a small depression, also water gets holded here. Okay, so natural depression is existing. If you want to increase the water holding capacity, you can enlarge this. You can extend this by digging the earth. So the amount of work involved in excavating the earthwork in this area will become less. Okay, so like that you can identify which are the areas where you can, which is the site which is suitable for construction of a reservoir, which is the site which is suitable for construction of a road. All those things can be you can come to a conclusion, like a preliminary conclusion, by seeing these topographic maps or contour maps. Okay, that is what I want to convey to you. A contour map is a must for doing any civil engineering project. In addition, a topographic map is also must in order to take a call. Okay, so best example here, I'll tell the same example. Here I want to extend this river. Okay, here I want to extend the river. So I need what is the contour value of adjacent these areas, as well as these areas, as well as these areas is also required for me. In addition to that, I also need a topographic map, because I want to know which area is going to get affected. Whether if I extend this river, or if I extend this tank towards all the sides, whether my houses are going to get destroyed, whether my agricultural land is going to get destroyed, or whether my forest is going to get destroyed. All those informations also need to be taken care while you are selecting a site. For that purpose, you need a topographic map in addition to a contour map. Okay, so is it clear? So in short, a contour map is definitely required for all your works for construction of any civil engineering activity. Okay, I'll share this PPT to you. Tomorrow morning, I'll continue again. Okay. Is the concept clear?
Yes, sir.
So what is a topographic map?
Yes, sir. It has all the features, including the agricultural vegetations and settlements, human settlements.
The contour map?
Only contours.
Only contours. What is a contour?
Elevations.
What is a contour?
Imaginary lines drawn.
Imaginary lines drawn
Of same elevations.
of same elevation. Where is the mean sea level for India?
Mumbai seaport.
Mumbai.
I am seeing only two ladies there, 90 and 113. Remaining all padkunara. Okay, we'll continue tomorrow morning at 10 a.m. Roll number 84. $112.
Present, sir.
117. 62.
Yes, sir.
65.
Sir, 117 present, sir.
67.
Present, sir.
68.
Present, sir.
69.
Yes, sir.
70.
Yes, sir.
72, 72, 73,
Yes, sir.
76,
Present, sir.
78,
Present, sir.
81,
Present, sir.
82,
82.
Present, sir.
87,
Present, sir.
89,
Present, sir.
91,
Present, sir.
92,
Present, sir.
93,
Present, sir.
94,
Present, sir.
95,
Present, sir.
98, 98, 100,
Yes, sir.
101,
Present, sir.
102,
Yes, sir.
103,
Present, sir.
104,
Present, sir.
105,
Present, sir.
107,
Yes, sir.
109,
Yes, sir.
110,
Yes, sir.
111,
Present, sir.
112,
Present, sir.
113,
Present, sir.
119, 119,
Sir, present, sir.
312, 312,
Present, sir.
313,
Yes, sir.
314,
Yes, sir.
315,
Present, sir.
316,
Present, sir.
317,
Present, sir.
318,
Present, sir.
319.
Present, sir.
Okay, right.
Sir, 319 present.
ఓకే
1884, sir.
ఇచ్చినప్పుడు ఏం చేస్తున్నావా
Sir, network problem ఉంది, sir.
ఓకే రైట్ బాయ్ ఫర్ ద డే